Hello, Algebra 2. Today we're talking about permutations. What are permutations? Well, permutations, what they are, we're going to be given options to find how many different arrangements we can find. Permutations, they're arrangements in which items, are not replaced and the order matters. Okay? The order matters. Now, another day we're going to talk about combinations, combinations are arrangements in which items are not replaced, but the order does not matter. This one, the order matters. So, for example 1, it says find the number of permutations of letters in the word until under the following conditions. The first one says the permutation ends with the letter U or the letter N. So if we think about it, we have 5 letters here. The letters U, I, N, T, U, N, sorry, I can't spell, U, N, T, I, L. So the last one has to end with U or N. So if you think about it, that gives us 2 options for our last number. 2 options. Well, if you think of one before it, if we've used one letter, that means there's 4 options left for this one, meaning there's 3 options left for the third, 2 options left for the second letter, leaving only 1 option left for the first letter. Again, the big thing is understanding that the last letter, there's 2 options, a U or an N. If this were a U, that means there leaves 4 different options for this letter, and then back, so on and so forth. So what we're going to do is we're going to take these values and multiply them together. So here we have 1 times 2 times 3 is 6 times 4. 6 times 4 is 24 times 2, which is 48. So there's 48 permutations. Okay? 48 permutations in which you're using these letters here, and the last letter is a U or an N. Okay? Alright, now let's look at the next one. How many even numbers with 1, 2, or 3 digits can be formed from the digits 6, 7, 8 if no digit is repeated in a number? Well, let's think about it. So we have a couple options. We have 1-digit numbers. Okay. We have 2-digit numbers. And we have 3-digit numbers. So let's think about the number of permutations here. So how many different options for an even number if you're only given 1 digit? Well, there's only 2 even numbers. So there's 2 here. There's 2 even digit numbers. Now it says a 2-digit number. Well, we have different options here. If you think about it, we have 2 spots. For it to be even, this side has to be a 6 or an 8. So there's 2 options. If you were to put a 6 here, that leaves a 7 and an 8 here, so there's 2 options for our first number. What's important, again, is this one. Since it's an even number, this has to end in 6 or 8, so there's 2 options, leaving 2 possible numbers remaining. Now here, 3-digit number, let's think about this. Oops. 3-digit number. For it to be even, it has to end in a 6 or 8, which is 2 options. Now, which leaves 2 other options for this one. If this was a 6, this has to be 7 or 8, so that's 2 options. If you use one of those numbers, there's only 1 option left for the first number. So what we're going to do is we have 2 up here for the 1-digit numbers. 2 times 2 is 4. We have 4 2-digit numbers. And we have 4 3-digit numbers. So, how many 1, 2, or 3-digit numbers can we form? And we add those up, so we get 10. Okay? 10 possible numbers. Okay? Again, if you're not fully grasping this, keep watching it. You can watch it over and over. And hopefully it's making sense. Now, example 3 says, 4 different biology books and 3 different chemistry books are to be placed on a shelf with the biology books together and at the right of the chemistry books. So we have chem books here, We have bio here. Okay, it says the bio books need to be on the right. Well, we have 4 bio books. 1, 2, 3, 4, and we have 3 chemistry books. All the bio books need to be on the right of the chemistry books. Well, let's think about it. There's 3 of them here. So out of the 3 possibilities, we can put one of the 3 here. So it's 3 options, leaving 2 options for the second spot, leaving 1 option for the third spot. Okay. Here, there's 4 bio books. Okay, 3 chem, there's 4 bio. You have 4 options for the first spot, meaning you have 3 options for the second, 2 options for the third, 1 option for the fourth. So what we're going to do is we're just going to multiply these numbers here. So we have 6 times, that's 12 times 2. 12 times 2 is 24. 24 times 6 gives us 144. So that's how many ways. There's 144 different ways that you can set up where 4 bio books are on the right, 3 bio books or 3 chem books are on the left. Alright, so 144 ways you can do that. So these are what permutations are. The next lesson we're going to get into a little more specific permutations called distinguishable permutations. So good luck with this today, and yeah, ask questions if you need help. Bye.